Hey everyone, and welcome to this second lecture on the introduction of three-dimensional geometry. Previous lecture was also on three-dimensional geometry, and in the end of the previous lecture, at the end of it, we basically decided that we're going to have another lecture on the introduction of three-dimensional coordinate systems so that we can understand this in a much better, simpler way. So in this lecture, we're going to go about discussing the same concepts that we did in the previous lecture, only in a bit more simpler manner. So we already studied two-dimensional geometry. We know that any point in the plane in a two-dimensional geometry can be represented by by a single pair representing 2 points, that is A and B over here as it is shown on the slide, which basically represents 1 point on the x-axis and 1 point on the according to the x-axis and 1 point according to the y-axis, that we call as the x-coordinate and the y-coordinate. So this is now called as a two-dimensional. One is the horizontal dimension x and the other is the vertical dimension y. This is known as a two-dimensional geometry. In three-dimensional geometry, what we do is we add another dimension to it. We add another coordinate to it, and thus the point becomes an ordered triple. That is A, B, and C. Now A, B, and C are actually on the graph represented by x, y, and z. So x and y we already have discussed before. X and y we already know what it is. And z basically is going to be the third dimension that we're going to be introducing. We'll see how to draw that axis and how it comes out to be the way it is. Now moving on. The way to do this, in order to represent any point in plane, the first thing that we need to have is a fixed point origin. Now the origin in the two-dimensional geometry and the three-dimensional geometry is the same. It is one point where all the axes meet. It is a point where x and y and z axis is going to meet, and it is a fixed point, and it is represented by O as well, just like it was represented in the 2D coordinate system. Then we have three direct lines through O that are perpendicular to each other. That would represent basically the three-dimensional systems, that three dimensions basically. So by perpendicular lines through the origin, that would mean the x and the y and the z lines, the x-axis, the y-axis, and the z-axis. So we have the three dimensions, and this is the way how we get it. So we'll call them x-axis, the y-axis, and the z-axis. This we know. Now this is the point that you need to understand. In the 2D coordinate system, we had an x-axis and we had a y-axis. What we did with that was that the x and y were actually perpendicular to each other. Now in three-dimensional geometry, what we're going to have is that we're going to have x and y, they're going to be horizontal. Of course, they're going to be perpendicular to each other. But in 2D systems, what I just said like a couple of slides ago is that we had x as a horizontal axis and y as a vertical axis. Over here, x and y are not going to be horizontal. They're going to be perpendicular to each other. That is, they are going to make a 90-degree angle with respect to each other, but they're going to be horizontal and on the horizontal plane basically, and z-axis will be vertical to both of these. How would this look like? This is how it would look like. So like you see, this is x and this is y. X and y are basically at 90 degrees to each other, and z is vertical to these two, and z is basically perpendicular to x and z is perpendicular to y. So first of all, let's take it step by step. The first thing that we discussed was that it is supposed to have a fixed point origin. This is their fixed point, O. This is their fixed point that represents the origin. Three lines that are perpendicular to the origin. So y perpendicular to each other. X is perpendicular to y. It makes 90-degree angle over here. X is perpendicular to z. Z is perpendicular to y, and x is perpendicular to y, and z is perpendicular to y, and z is perpendicular to x. So you see, all of these three lines are basically perpendicular to each other. And as you can see, x and y are basically on the horizontal plane, and z, that is the new dimension that we have introduced, is the vertical line. So this is how a three-dimensional coordinate system looks like. Now, how do we draw this? How do we draw the z-axis? Where would we know that the z-axis is? So the way to draw this is known as a right-hand rule. What you do is that you look at the diagram and you basically curl up your fingers around the z-axis in the direction of 90-degree counterclockwise from the positive axis to the positive y-axis. That is, if you look at this hand, just forget about what is written over here, just look at this hand over here. So you see, this is going to represent the z-axis, that is going to be represented by the thumb. So you have a hand. First open up your hand like you're gonna open up to shake someone's hand. Now try to make a fist. Now try to make a fist and let the thumb remain where it was before. And that is pointing upwards. And so it's like you're saying good luck to someone. So you see, once again, if you do it, if you have your hand open fist and you're trying to make a fist, you slowly close it. So you see your hand, your fingers are going to move in the counterclockwise direction. That is the direction opposite to which the arm of a clock moves. So that plane is going to represent the x and the y axes, and thumb is going to represent the z axis. This is the easy way to understand where and how you would make the z axis. Once that is done, you're going to have these planes over here. Now this is the way to basically visualize this 3D plane. So this, of course, now if you just look at it, you don't even have to remember this. X and Z, of course, this plane is going to be represented by the X and Z plane. We're going to call it the X and the Z plane. Then we have the Y and the Z, this is going to be the YZ plane. And we have the X and the Y, this is going to be the XY plane. So this is how you have to do it. X and Z is any plane will be called by the name of the two axes that it is between. So X and Z is between the X and the this plane is between the X and the Z plane, and this plane is between the Y and the Z axis. So this is going to be called the Y and the Z plane. So this makes an an octet, because you see this is being divided by the whole system is going to be divided into 8 parts. We discussed this in the previous lecture as well, and I described to you how this makes 8 parts, why this is an octet. Now I want to further make it easy for you, because many people have some difficulty visualizing diagrams in 3D figures. But you see, you're actually sitting in a 3D figure right now. That 3D figure is your room. Now just look at the room, and this way we'll understand what the 3D coordinate system is. So we have a floor, we have a left wall and a right wall. So you see, imagine this going from one corner. Imagine the corner that you're sitting the corner that is in front of you. Imagine that to be the origin, and this is the x-axis, and this is the y-axis, and this is the z-axis. That is the wall. That is the axis from the floor to the roof. This is called as the z-axis. So if you have these, just look at these over here, and now let's look at it step by step. The wall on the left is the ZXZ plane. This left wall is the ZXZ plane. Why? Because it is between the x-axis and the z-axis. And the wall on the right is a YZ plane. This is the wall between the y and the z-axis. And of course the floor is the XY plane. So try to visualize this. You can even look around if you want. You can put something in the corner to visualize, call that thing an origin, so that you may understand this in a better way. Now the x-axis runs along the intersection of the floor and the left wall. That is, the x-axis is going to be representing this area over here. That is the point from the origin in the direction of x. The y-axis will be the same as well, in the opposite direction, of course, y over here in the right wall. And the z-axis, of course, the new axis that we have introduced over here, is the axis that runs from the floor towards the ceiling, towards the roof. That is a z-axis. You can even draw, you can even see this with the thumb placement by using the right hand rule. Now since you're sitting on the floor, this is because this is the positive y and the positive x and the positive z axis. So this is called basically the first octant. Of course, I would say that you go back to the previous lecture to see all the other 7 octants, because that is the way how we have discussed it so far. That is the way how you can understand it in a better way. So I would suggest you go back to that and you try to understand that in the particular way that we discussed over there. Now let's try to make a point. Now this was only to show you how you should visualize a 3-dimensional coordinate system. If you want to actually understand this, how this happens in the x and the y and the z axis on the graph, this is how we're going to do it over here. So you see, we have 3 points over here, A, B and C. Basically they represent the x coordinate, the y coordinate and the z coordinates. And we have this point over here, we have the x, y and the z coordinate systems over here. So A, B and C, point is going to be representing A. That is, A will be the distance basically from the origin in the direction of x. B will be the distance from the origin in the direction of y. Of course, we've shown it over here to make it easier for you to understand. And of course, Z will be the direction from the origin in the direction of the z axis. Once this is done, this has been done, we move on to describe So you see, if you look at it, you can make a rectangular box out of it. That is, if you draw it in every direction, if you draw a line in every direction, you can make a point out of it. But this is just to visualize the stuff. Since this point is basically, if you look at it, this is basically in air. This point is in between, all the three axes. If you want to see where this point ends up on the x-axis, that is, you will have to project this point on the xy plane. If you want to see the point on the xy plane, then you will have to project it. So you're going to get q out of it. Of course, since it is the one point to remember over here is, if you look at this q over here, that is a comma b comma 0. So xy plane will have 0 on the z-axis because it is on the xy plane. You're not going to have any z coordinates over it since it is on the plane itself. Just like if it were on any other plane, it is not going to have a third coordinate over there as well. If you want to see the point being projected on other axes, on other planes, then you can see that r is the projection of p on the yz plane, and of course the r over here will be 0 comma b comma c. That makes sense because we don't have an x value on the yz plane. Just like that, you're gonna have the x s for sand, the projection of the s, which is a projection of y, which is the projection of which is the projection of p on the xz plane. And of course you're not going to have any y value over here, so that's going to have a comma 0 comma c. So I'm sure this is pretty easy for you to understand. This is just a numerical illustration of if you have to represent, this is basically shown in a 3D manner. If you want to represent -4 comma 3 comma -5, so -4 is of course going to be the negative value of x. So this is the positive x axis. So -4 is going to be someplace over here. So this represents -4 over here. Now since we've gone over here, we're going to see 3. Now 3 is a positive y. Then we go into positive direction of y. We get 3 over here. Look at this purple line over here, pinkish purplish line, and this is going to tell you how to find the answer to how plotting this point. Then we go in the negative direction of 5 negative directions in the z axis, and then we go down from here. We get this point. Now let's make another one as well. Before you see this diagram, it would be good if you can draw this yourself so that it is much more easier for you to understand and the concept is ingrained on you. First thing to do is go in the positive x direction and represent 3. So we started from the origin, we go in the positive x direction, we go 3 points in the positive x direction. Then we go -2. We go -2 points in the y direction. That is the negative part of y. We go towards there. We go from here to here. And the next thing we have to plot over here is the -6. That is in the negative part of the z-axis. 6 points in the negative part of the z-axis. So we go down and we get to this point over here. Once we're done with that, we have drawn this over here. Now let's look at some example. Where would we find z is equal to 3 and y is equal to 5? What would this be in the 3-dimensional? What would this be? So before I answer this, try to find an answer. Try to answer this yourself, so that once I get there, you would know whether you grasp the concept or not. Z is equal to 3. So basically z is equal to 3 is going to be a plane in the xy, parallel to the xy plane, and 3 units above that plane. Why is that so? Because you see z is equal to 3 means that it's not going to have any x or y value. So since it's not going to have any x or y value, it has to be purely on the z axis. So what we're going to do is we're going to put one point on the z axis. That is going to be 3 over here. Once we have plotted this point over here, we know that this is going to be a plane that is going to be parallel to the x and the y plane. Of course, x and the y plane have no role over here. So this, as you see, was pretty simple. Now moving on, let's try another example. So in this example, we're going to have y is equal to 5, and since we know there is no x and the z-axis over here, we're going to plot y is equal to 5 over here. Once we've done plotting that, we know that this is now going to be a plane, since it is a single point, and this point basically is a point on the y-axis, but it represents a plane. So because it is only singular, it has no x and the z value. So this is pretty much it. I hope now you have the understanding. Now it is easier for you to visualize three objects in three-dimensional coordinate systems. This was the distance formula that we studied in the previous lecture as well. Just same as distance formula between two lines, and the only difference is that now it's going to have 3 points in it. There's one more formula that we need to discuss, and I'm going to discuss this in the next lecture. And in the next lecture, we're also going to start with probability. We're done with the coordinate systems. We finished so far we have done complex numbers and coordinate geometry. Now we're going to start with probability in the next lecture, and one other formula that I want to discuss with you. And right now, as you can see on the screen, we have this distance between 2 points, P and Q, and the same, it's just you're plugging in the values, taking a square and then the root, then you can find the value between these 2 points in three-dimensional coordinate systems. So thank you very much. Hopefully I'll see you again in the next lecture. Bye.